the triangle congruence and its rules. Basically, what are the rules that you can use to prove that two triangles are congruent, meaning same size and shape? We've been talking about that. This symbol in geometry that talks about size as far as the equal sign and shape as far as something that's similar in shape. So what you're presented with are certain rules as far as, let's say if I built a triangle and I gave it sides 8, 10, and 7. Right? I drew this triangle. All right, let's say we'll put it in inches. Right? 8, 10, and 7. And I tried to draw another triangle with the same exact sides. It could be upside down or rotated, reflected. Okay, and I draw this same triangle. It would have to, by definition, be the exact same triangle. There is no way I could draw two triangles to be different if they have the same exact sides. And the rule we use for that, when you have basically 3 pairs of sides that are congruent, is we call this the SSS, or side, side, side rule. Okay? SSS. That means you're able to look at 2 different triangles, identify that all 3 sides are the same, okay, and identify, okay, these 2 triangles are congruent, same size and shape, by SSS. There's another triangle that you could draw. Now let's just say I took a side of, I'll be using maybe 10 a lot today, 10 degrees, right? And then, or 10 inches. And then let's say I use a 40-degree angle. Any 40-degree angle with a 6-inch side. Let's say, okay, I have a side, I created a side. Basically, I created an angle with a certain measurement for one of its sides and another measurement for another one of its sides. Now, once I connect here, this is going to give me a certain measurement, let's just say, okay? Now, if I decide to take the same side, 10 inches, and use the same angle, 40 degrees, and use another same side, 6 inches, I would have had, in fact, drawn another pair of triangles that would have to be congruent, because this distance from here to here would have to be the same, because I've given you a certain distance of 2 sides and a certain angle. So this, whatever this is, let's say, well, we know that it can't be 4, because 2 sides of a triangle have to be greater than a third. So let's just say it's 5. Let's just say it's 5. Let's just say. It would have to be the same. And then the rule we use for that is that, well, what do we have? We had a side congruent, we had an angle congruent, and we had another side congruent. So we like to say for this rule, side, angle, side. Side, angle, side. So if you're given in any problem or shown that you have 2 sides of a triangle, and what we like to say is included angle, right? So identify this as the included angle. Now, why do we say included angle? Well, we say it's included because it's the angle in between the 2 sides. An example of something not included would be a side, and then another angle. Okay, this would be an angle that's not included. Or, I'm sorry, this would be an example of an angle that's not included. Okay, you need, and we'll see why there's a problem with this. We'll see why there's a problem with this when we talk about rules that don't prove triangles congruent. So here you have an example of side, angle, side. Another example you guys could work with, okay, is let's say I take a certain side length. Again, let's just use 10. Okay, let's just use 10. And off of this 10, I draw a 40-degree angle and maybe a 50-degree angle. Okay? And then let's say I continue until these two intersect, and I end up with a triangle. Yeah, it would have to be about 90 degrees. Okay, if I did the same exact thing, and I could do this with this triangle, let's say I reflect this triangle, and I'm putting the 40 degrees here, and I'm putting the 50 degrees here. Both of these angles, right, end this side, and connected to, I'm going to end up again with two congruent triangles, because in this case, I've had two angles congruent, along with an included side. Angle, side, angle. And again, we see this as included because in order it goes from angle, side to an angle. Angle, side to an angle. It is not going angle to an angle, then to a side. This would be an example of a non-included side, which kind of leads me to talk about our next example, where you can have, let's say I draw a triangle. Again, we'll start with, actually this time let's start with an angle, maybe 30 degrees. Let me create another angle, let's say 80 degrees. And then let me make a certain side length of 10. Okay? Let's say this is 30 degrees. Now here I have an angle, and a side. And this would connect, and this would give me basically 70 degrees here. Okay, if I were to draw the same thing where I had a 30-degree angle and an 80-degree angle with the 10-inch side connected to the 80-degree angle, so it kind of corresponds there, I would end up again with a congruent triangle, because in this case I've had two congruent angles, and then what we would say here, a non-included side. So here's the distinction between the two. Here you have an angle that goes to a side to an angle. Here you have an angle that goes to another angle and then goes to another side. So this rule we would call angle, angle, side. Okay, the last rule you guys could use would be what they call the HL rule, where, and we know in a right triangle you have a hypotenuse, what we call a hypotenuse, which is opposite the right angle, and you have any one of the legs. So if I end up drawing a right triangle, let's say a side length of 4 and a hypotenuse of 10, and I draw the same right triangle which also has a hypotenuse of 4 and a leg of 4, then I would have what they call HL, which is, again, hypotenuse leg. So here's my matching hypotenuse, and here's my matching leg. Now, a lot of times when you see that right triangle, you know, you're going to already start to look at the hypotenuse and leg as something that could be a rule for that. But be careful that your sides of your leg of your right triangle match up. Now, something we want to look at is we want to look at some rules that don't apply. Maybe some cases where I could draw two triangles. For instance, let's say I drew a triangle. A good one to draw would be an equiangular or equilateral triangle, 60, 60, 60. Okay, here I've drawn all angles the same. I could draw the same triangle, in this case, 60, 60, 60. Here you see I've drawn two triangles with the same exact angles, but I'm able to draw in a way in which they're not congruent. So angle, angle, angle is not a rule that you could use to prove triangles congruence. Now, in comparison to something like this, if I draw any angle, like 40 degrees, with a certain side, with a certain 50-degree angle, if I draw these three things in order, and then try to draw them again, the triangles would have to or will always end up to be the same. As long as I have two pairs of angles and the included side the same, there's no way I cannot. If I took out a ruler and a protractor and I tried to draw these two with the same angles and the same side, there's no way I could draw them and have them not be congruent. Where in this case, you could see right away. Now another one that doesn't work as well, okay? And we don't have to look as, but if there is something that you see from this that can remind you as it not working or stands for something, let's just take a look. I could draw a 50-degree angle. I could draw a 50-degree angle with a 10-inch side and I can have it come this way with 8 inches. Here I have an angle side, okay? Angle side, or I could take the same triangle. No, it would have to be 10 inches. With a 50-degree angle, draw a 10-inch side, but I can put this side, instead of coming in this way, I can draw it out this way, 8 inches. And here I have two triangles. Yes, they have a matching angle. Yes, they have a matching side. Yes, they have an additional matching side, but they are not congruent. So this rule, angle side, is not a rule because I can draw these two triangles to be not congruent given a congruent angle side and side. Now some examples that you guys would want to see or want to look at with some hidden features. Let's just say I gave you a triangle that looked like this. And I'm asking you for the rule. I'm asking you for the rule here. And I give you a side. Now, we know these are the same because they're single slash. We know these two are the same because they're double slash. But you say, well, it doesn't tell me anything about angles, and I don't have that third side. But what you have to consider is that these two triangles are sharing what we like to call a common side. Meaning, there's a side that both triangles are using to create their shape, and because they are the same, and they're using the same exact side, it'd be like if two people are using the same exact item. You're using the same jacket, it's no different. Okay? You use it on whatever it is that you're using on alternate days. Let's say this person uses it one day, the next day it's the same. It has to be the same thing. So if you see a common side between two triangles, identify that as a congruent side, which would allow me to identify this triangle as congruent by side. Another hidden feature you might see is that they may give you an angle and an angle, single arc telling me these two angles are the same, and they may give me a congruent side here, and say, oh, okay, I have angle, I have side. I have angle, I have side. I don't know where to go with this. Well, we've learned two angles, two non-adjacent angles, or two angles created by non-adjacent sides. We call these vertical angles. And we know vertical angles to be congruent. So we could say these two angles congruent, giving us an angle, an included side, and a following angle, so we could get something that would be angle side angle.